Hello and welcome to day 74 of Anatomy Physiology. On the screen you can see the warm-up questions. They'll be due on day 75, so pay attention to that. The questions here refer back to day 74. I'm going to move past this. You can go back to day 74 and day 73 and check check there for your answers. Here we've got our moment of silence. You can pause the video if you want for a quick moment of silence. It's been a while since we've had a chance to kind of talk together the class, but it's been a heavy couple of weeks here. So moving on. Back to warm-up questions. You can, again, like I said, you can check back on day 73 if you've got questions on those. Class business, unit 5 online test, rewrites, directions are on Canvas. So email me if you have any questions or message me if you have any questions. I'll get back to you on that. Unit 6 online test. There will be a Unit 6 online test. It'll be slightly shorter because we're just going to cover the immune system and respiratory system for this test. So we'll finish our notes for Chapter 13 and do Labs 23 and 24. Looking at tentative dates of May 1st and May 4th. That's a Friday and a Monday. Hopefully that'll work. I understand there may be some changes to the schedule a little bit, but that's kind of what I'm looking at for now. Homework. MyLab and Mastering, chapters 12 and 13 are up there. Lab 23, Lab 24 is up there. And then keep the immune system games coming in. I've really enjoyed the ones that have come in so far. They're pretty clever. Again, just another different way to look at the homework. And then respiratory system, we'll finish up with the respiratory system today and work on Lab 24. I'll give you some directions on that. Yeah, that's our kind of header there. Kind of the what, how, and why, the respiratory system, what it does, how it does it, why it's important. So if you want to watch the video, you can. This is from the TV show Survivor. This is just one particular little video clip where they're holding their breath underwater. Feel free to watch it. If you want to try to hold your breath with them, don't do it alone. I don't want anybody to pass out because that is a possibility. So if you've got somebody who can watch you while you do it, go for it. See if you can hold their breath. I think the champion on there is about 2 minutes or so on that for his breath hold capability. So we're going to continue on with respiration. So we call external and internal respiration and what's happening there. So the key thing that we're looking at is how do we actually get gases to move the direction we want them to move, oxygen into the blood and carbon dioxide out of the blood. It has to do with diffusion, which is the movement of areas from high to low concentrations. So the air around us has relatively high oxygen concentrations, about 20%, give or take a little bit. The oxygen in our blood is lower than that, 10, 12%, something like that. And then CO2 is kind of flipped. I forget their exact numbers, but it's flipped as well. So here you can see the inspired air, relatively high oxygen, relatively low CO2. This is the blood coming into the alveoli of the lungs. So oxygen is a little bit lower than that. So oxygen is going to move into the blood. CO2 is higher. And what that is, so CO2 is going to move out of the blood. So that's where you see that CO2 moving out, the oxygen moving in. And it's going to go through kind of the body until we get down here. It's just kind of in the blood until it gets down to our tissues. And the reverse is going to happen. So this oxygen level in our blood is higher than that oxygen level in our tissues. So it's going to move into the tissues. This CO2 level here is higher than that CO2 level there. So the CO2 is going to move out of the tissues. And then we've got our venous blood, relatively low oxygen, relatively high CO2, and then it's going to go back here, and that's going to reverse the process and repeat. So we call this gas exchange that happens in the lungs, oxygen loading, and carbon dioxide unloading. You can see that exchange happening there. And then we move on, so it's kind of a visual. You can see oxygen moving into the red blood cells, CO2 moving out. We'll talk about some of the specific things, but the key thing is that oxygen binds to the hemoglobin, and then the carbon dioxide is traveling in the blood in something called bicarbonate here. So there's the oxygen attached to that hemoglobin molecule. It forms a big molecule called oxyhemoglobin. You don't need to worry about that name. It's just hemoglobin is the thing we want to focus on. There's a small amount of oxygen that's carried in the plasma, but not really too much. And then, again, that's oxygen to oxyhemoglobin in the red blood cell there. Carbon dioxide travels in the blood in a molecule called bicarbonate. You can see kind of the visual representation here. So carbon, there are 3 oxygens. and then the one hydrogen kind of off to the side. Small amount is carried inside the red blood cells, but most of it travels in the blood plasma as bicarbonate. So for carbon dioxide to diffuse out of the blood into the alveoli, it must go from bicarbonate to carbon dioxide. There's some chemistry that happens, but don't worry too much about that. Just bicarbonate and CO2 is our key things that we're focusing on. Again, you can see that image, CO2, it starts as bicarbonate, becomes CO2, and then gets into the alveoli, diffuses that direction. So internal respiration is what's happening inside the tissues, between the blood and our tissues. It's the opposite of what we had happening in the lungs. So carbon dioxide loads up into the blood. It's coming from the tissues. Oxygen goes from the blood to the tissues, so oxygen is unloaded. Right, again, you can see image. So the oxyhemoglobin over here drops the oxygen off. The carbon dioxide goes into the blood and ends up as that bicarbonate ion over there. Okay. So what controls our breathing? So we have control of respiration, how quickly we breathe. So there's neural regulation. It's transmitted to and from the brain by what we call phrenic and intercostal nerves. These are controlled ultimately by the medulla and the pons. The medulla sets the rate, the basic rhythm of breathing. It has a pacemaker for breathing, kind of like we had a pacemaker for the heart, but it has a pacemaker for breathing. And then the pons smooths out. So if you really quickly jump from quick short breaths to long slow breath, the pons is kind of what helps you space that out. So you're making sure you don't get kind of caught up in your breathing there. Normal respiration rate is 12 to 15 breaths per minute. Kind of like we measure heartbeats per minute, we measure breaths per minute. The term for this is eupnea. EU means true, so and then PNEA refers to pneuma, or breathing, so true breathing, 12 to 15 breaths per minute. I've been told that doctors or nurses, if they're going to take your breathing rate, a lot of times they won't tell you they're doing this because people become self-conscious and they'll actually hold their breath if they think somebody's counting the number of times they're breathing. So they'll come in, they'll pretend to do something else, like take your heart rate when they're actually monitoring your breathing. That's what I've been told. I don't know if it's true. If somebody knows, let me know. It'd be kind of fun to find out. Hyperpnea is breathing fast. Oxygen needs usually dictate that. Maybe you're low on oxygen, you've been running or something like that. Oh, and I should go back real quick. So there's another kind of category that's in there that's we call apnea, which is without breath. So A is without. So apnea is not breathing, intentionally holding your breath. You may have heard of like sleep apnea. So moving on here. So again, we've got our pons and medulla kind of coming into play here, innervating through the phrenic and intercostal nerves, the intercostal muscles, the ribs, and then the diaphragm down below. And then what kind of stimulates those is we've got oxygen sensors in the aorta and other areas, and then we've got CO2 and then H+, so hydroxy ions, measuring how acidic the blood is, kind of happening in the brain there. And those send signals, again, kind of back into here to tell us what we're going to do there. So physical factors, non-neural things. So physical factors could be body temperature, exercise, talking, coughing, can influence the rate of breathing. Volition is just conscious control. You can intentionally choose to breathe faster or slower. And then other things like emotions come into play as well. If we're angry or fearful or happy or whatever, we breathe different than if we're just kind of hanging out. That's part of that fight or flight response there. Chemical factors like CO2, it's the most important stimulus for breathing. Our body needs to get rid of that CO2. So if there's an increased level of CO2 and the decrease in pH, which makes the blood more acidic, then we want to really dump that CO2 out. And so changes in CO2 act directly on the medulla oblongata, actually as a monitor that detects how much CO2 is in the blood there. And then oxygen levels also come into play. So changes in oxygen concentration. There's chemoreceptors in the aorta and the common carotid artery that detect how much oxygen is there. That's also sent up to the medulla. But oxygen is actually secondary to CO2. They've done experiments where they have people on a mask that they're breathing through, and they'll actually dial in the amount of oxygen or the amount of CO2 that they're breathing. And if they fiddle with the oxygen, people don't tend to notice too much. But as soon as they start fiddling with the CO2, people respond to that right away. and alter the breathing rates accordingly. And then finally, we've got hyperventilation, again, which is kind of really, really rapid breathing. So this results in rising levels of CO2 in the blood. Acidosis results in faster, deeper breaths. So we exhale more CO2, and this results in higher blood pH. Can result in apnea, dizziness, and lead to alkalosis, which is alkaline blood. So pH goes up and becomes more basic. So hypoventilation, when blood becomes alkaline. This is extremely slow or shallow breathing, and then CO2 accumulates in the blood there as well. All right, and I think that gets us to our stretch break. So we'll go ahead and take a quick stretch break, and we'll come back for part 2. All right, thanks for listening to part 1.